This is part 4 of the lesson that addresses the competency derived inductively the relations among chords, arcs, central angles, and inscribed angles. Specifically, we will be talking about arcs, chords, and central angles. An arc is part of a circle. From our figure, these are some of the arcs. Arc AB, which is this one. Arc BC, which is this one. And arc ABT, so that's this arc. From A, then all the way to D. A central angle of a circle is coplanar with a circle. Its vertex is the center of the circle. In our figure, angle AOB is a central angle. So this angle. A minor arc is a short arc joining 2 points on the circumference of a circle. This arc here, which is a short arc, arc AB, is called a minor arc. A major arc is a long arc joining 2 points on the circumference of a circle. So arc ABT is a major arc. So this arc from A all the way to D. A semicircle is an arc whose endpoints are endpoints of a diameter. From our figure, arc DCB is a semicircle. So this arc. And also, arc DAB is a semicircle. So this arc, DAB. The degree measure of minor arc AB is equal to the degree measure of central angle AOB. So this is the degree measure of arc AB. It's equal to this angle, angle AOB. The degree measure of major arc DBA, so DBA, is equal to 360 minus the degree measure of central angle AOD. So this one. So the degree measure of this equals 360 minus the degree measure of this angle. The degree measure of semicircle DAB equals 180 degrees. So this one, DAB, it's 180 degrees. In the same circle or congruent circles, congruent arcs are arcs that have the same measure. So in our figure, given that measure of arc EA equals measure of arc AB, so this follows that arc EA is congruent to arc AB. We have 3 theorems here. This is the first one. In the same circle or congruent circles, congruent arcs determine congruent central angles and congruent chords. So given that arc EA is congruent to arc AB, so this follows that the central angles, angle EOA, this one, EOA, is congruent to angle AOB. So this one, AOB. So these 2 angles are congruent. And also congruent chords. So that means chord EA, this one, is congruent to chord AB, this one. So this is the second theorem. In the same circle or congruent circles, congruent chords determine congruent central angles and congruent arcs. So from our figure, it's given that chord EA is congruent to chord AB. So this follows that the central angles, angle EOA is congruent to angle AOB. So these two angles are congruent, and also congruent arcs. So meaning to say, arc EA is congruent to arc AB. So this arc and this arc. The third theorem, in the same circle or congruent circles, congruent central angles determine congruent arcs and congruent chords. So these are the congruent central angles, angle EOA and angle AOB. So this follows that arc EA is congruent to arc AB. So this arc is congruent to this arc. And also congruent chords. So that's line segment EA, which is this one, is congruent to line segment AB, this one. Now we are going to do problems applying the three theorems. In our figure, angle AOB, which is a central angle, measures 40 degrees. Find the following. Letter A, angle DOC. So this is DOC. Since angle AOB measures 40 degrees, this follows that angle DOC also measures 40 degrees. How about arc DC? This one. So since angle DOC measures 40 degrees, this arc also measures 40 degrees. How about arc AD? So this arc. So this arc here also measures 40 degrees because the central angle measures 40 degrees. And from B to D, it's a semicircle. So meaning to say, from here, from B to D, it's 180 degrees. Since this is 40 degrees, this means arc AD equals 180 degrees minus 40 degrees, which is equal to 140 degrees. How about angle BOC? This one, angle BOC. So since this angle measures 140 degrees, this angle here also measures 140 degrees. How about arc ADC? ADC. So from A all the way to C, it's a semicircle. So that means arc ADC measures 180 degrees. How about arc BDC? So BDC. So from B to D, it's a semicircle, it's 180. And because this one here is 40, so this means this is also 40. So we have 180 plus 40. And 180 plus 40 is 220. So that means the measure is 220 degrees. Problem number 2. In our figure, line segment AB, which is a chord, measures 7. And arc AE, which is this one, measures 65 degrees. Find the following. Letter A, arc CD. So this arc from here to here. So this arc here is just 1/4 of the circle. So 1/4 of 360 equals 90. So it's 90 degrees. How about angle AOB? AOB. So it's obviously a right angle because this one here is 90 degrees. So this follows that this angle here is also 90 degrees. How about angle EOD? So it's this angle EOD. We know that angle AOD measures 90 degrees and this one here is 65 degrees. So that means angle EOD equals 90 minus 65, which is 25. So our answer is 25 degrees. How about arc BDE? So arc BDE is this one from here all the way to here. So we know that arc BD is a semicircle, and we know that this arc here measures 25 degrees. So that means 180 plus 25, and 180 plus 25 equals 205. So that means our answer is 205 degrees. How about arc ABC? So arc ABC is this one from here to here. So it's obviously a semicircle. So this measures 180 degrees. How about segment BC? This segment. So we know that this arc here measures 90 degrees. This arc here also measures 90 degrees. And the chord here is 7. So that means this chord here from B to C is also 7. How about angle BCO? So BCO. And we know that OB equals OC. So this follows that this angle here equals this angle. Since this angle is 90 degrees, this follows that angle OBC equals angle OCB. Each of these angles measures 45 degrees. Thanks for watching, guys. This is teacher Rejil. Keep safe.